Okay, we've practiced a polynomial, we've practiced a radical. Let's practice another rational here. And we're just going to compute the derivative. So if I have g of t is 1 over t squared. So we're just going to compute our derivative. We're not worrying about the slope of any kind of tangent line at this point, just our derivative. All right, so we have the limit as h approaches 0 here of 1 over, and I'm going to, t is my variable, so I'm going to keep t as a variable. So t plus h squared, because I'm plugging that in, minus 1 over t squared all over h, right? Now, you're getting a common denominator. With that common denominator, I'm going to multiply the top and the bottom. You got to represent. So what's my common denominator? Both t plus h and this t squared. This is a binomial. So you FOIL that out. I'm going to go ahead and FOIL that out to be t squared plus 2th plus that h squared, and have this t squared that I'm multiplying by that. Do you see that? That way it's just easier. All over t squared plus 2th plus h squared times that t squared. So when I multiply, this cancels out this. It's just multiplied out, but those mean the same thing. So my numerator here is just multiplied by that t squared, because this cancels out with this, potentially, right? Okay. Get that off there so it's not confusing. Then my t squared cancels out over here with this t squared, and then my numerator here is multiplied by a t squared plus 2th plus that h squared. And then my denominator is everything. So let's do it right now. So g prime of t is equal to my limit as h approaches 0 of t squared minus t squared plus 2th plus h squared all over h times all that business. I'm going to bring that t squared in front just because it doesn't need its own sets of parentheses since it's a monomial. T squared plus 2th plus h squared. Same thing here. I don't need that parenthesis right there. We could put it there. It works. The kicker to this, though, is you're still subtracting here, so make sure that you're distributing that negative. Okay. Now, clean it up. There's always stuff to cancel, right? Positive t squared minus t squared, because the goal is whatever's left over is always going to have h's in it that you can factor out. You see in this pattern that happens for us every time? So I have the limit still as h approaches 0 of negative 2th minus h squared all over ht squared, and then all of that. 2th plus h squared. If I factor an h out of the numerator, so the limit here as h approaches 0, if I factor out an h, then I'm left with a negative 2t minus h over ht squared, t squared plus 2th plus h squared. Yes, it is boring to rewrite that all over and over again. However, you need to figure out what it is that you have. If you try to skip too much, you're going to miss something. That's where errors happen. So just keep writing it out. Organization, right? 98% of success in mathematics is what? Organization. I'm going to keep beating that drum. 2t minus h over t squared plus 2th plus h squared. Now look what happens. After all that, I'm going to take this h and plug in a 0 everywhere I see an h. Oh, now that looks cool, doesn't it? So now I just have a negative 2t over t squared times t squared, right? Because both of those are zeros and the t squared is all I have left. Clean it up a little. One of these t's takes out one of those. So what I actually have left is g prime of t is equal to a negative 2 over t cubed. Cool, right? Yeah. It's not bad. Algebra, algebra, algebra. And this is really good. I really like doing these because it does a really good job of helping us practice our algebra skills. Okay. All right. So now we've had a little bit of extra practice using the difference quotient and the limit definition. Now we're going to move on to something with our graphing. So here we go.